I'd like to introduce you to the first talk here in the technical session on Pinterest. We've been running as part of QCons that we also engaged in. We've been running these architectures you always wondered about kinds of sessions, and it's always great to see these large startups, large companies doing really crazy stuff. So here's a story of scaling Pinterest, scaling from a couple of computers. Marty has been with Pinterest from the very, very beginning. So there's lots of really cool stories from scaling there. It's not as technical, all the way through. I was sitting, last time I watched this, I was like itching to to hear how exactly did they do that sharding or these more technical details. But on the other hand, it's really nice to have this kind of nice, simple story, and it kind of sits in opposition to this whole conference. Here at the conference, we talk about all these new things, all these new fancy technologies, and I really like the message in this talk that you have to keep things simple to make them scale. So please welcome Marty.
Thank you. Hey, well, I don't have to intro myself now, but so I'm from Pinterest. Been there for a while. Today I'm going to take you on a mystical, magical tour of what it was like to build Pinterest from the ground up. I'm going to go through our evolution, our technology, and I'm going to show you some of the lessons we learned and many of the many mistakes we made. And my hope is that you won't make the same mistakes, but instead make all new, exciting mistakes. So first, the evolution. We started in March 2010 and launched to the world, and sort of quietly, I guess. At the time, we were trying to figure out how to make the website. So what was the website? What are we building? Images here, followers. We should have followers. That seems like a good idea. We'll need a feed. We'll need aggregation. We'll need all these things. And what that usually looks like is you've got two founders eating Doritos and ramen, and you got an engineer that they found somewhere. That's what we had, and it was really great. It's a really fun time because you're trying to figure out what you're building, and you're moving fast, and the engineer's cobbling it all together and making it look right. But the underlying bits are just barely held together. But you're optimizing for speed of design over engineering just yet. So here's the three. It was Ben Silberman, Paul Sciarra, and Yash Nelapati. And then for the next 9 months, we were in what the founder called, we were in stealth mode, but not because we wanted to be. Went for a little while, a little bit of engineering, a little more product dev behind the scenes. We had swapped cloud services. At this time, if you recall, cloud services have been around, but then they were starting to kind of really get big, and people were really debating, should we be on the cloud, should we be in data centers? I think we swapped over to Amazon because it looked new and exciting. I think we may even had some credits, I don't know. We started to have a little bit of differentiation in our stack so that we can, maybe have a little more redundancy and things like that. So we had an Nginx at the top, and we actually had 4 web engines running Python. We had a read slave for MySQL so that you can offload a little of your reads, and a task queue so we can send emails and tweeties and Facebookies and MySpacies and live journals and all that good stuff. And then we had a MongoDB box, because everybody has a MongoDB box, for counters. And then I joined around that time. And here we are. This is a little example of what it was like. This is at our international headquarters in early 2011. Behind us is the apartment that we worked out of. In the main area, we worked. And then there were 2 bedrooms, and one bedroom was our international boardroom where we had our grand meetings. And the other room was actually a bedroom. So then the thing happened. The thing took off, and it was kind of a crazy ride, and we never slept or anything. And what happens during this kind of a ride is that everything's on fire. We only had a few engineers, and everything gets hot. We were doubling every month and a half. So your databases are angry, and people are coming to your doorstep saying, hey, if you just use my magic technology, we'll solve all your problems. So you're like, yes, gimme. And what happens is this. And you're not meant to read this. You're just meant to be terrified by it. I'll give you a quick rundown. Look, we've got how many databases? We've got MySQL, Cassandra, Membase, Memcache, Redis, Elasticsearch, and MongoDB. And we had 3 engineers. So You have to be an expert in all of these, and we were not. So it was one of those problems where each one comes along, it solves the problem for a couple weeks. You're elated. This is awesome. And then when the honeymoon period's over, you start to cry a little bit. So we learned the hard way. It will fail. Every one of these will fail. So keep it simple. When the time comes, it's 3 a.m. and it fails, it sure would be nice if you could find the answer pretty easily. The other thing we learned as we grew and we started to become the biggest users of these different technologies is that whenever we were the biggest user, everything was 1,000 times harder because nobody has tripped over those landmines for us and then written tools. As we tripped over the landmines, we wrote tools to fix them so someone else could use them. But we were the first ones on many of these, so lots of pain. So here we are, roughly early 2012, and we had moved into Palo Alto downtown. And this was huge. This space was amazing. There was an echo. It was crazy. That didn't last too long. So the scaling kept happening, and around January 2012, we finished a massive re-architecture. So roughly around November or October 2011 to 2012, we decided to re-architect everything. It was all on fire. It sucked. It was too damn complex. So we said, what works? And I'll go through how we made these decisions, but we got down to first principles of good engineering. What works and what is it we actually want? What are we actually trying to build? And we got rid of most of it. So now we've got MySQL, Redis, and Memcache. And really, we could have done it on MySQL and Memcache, but Redis was working so well, we decided to keep it around for a couple of really important tasks. So we got rid of all the other things. And then the ideal in any scalability project is that you could just throw boxes at the numbers. The financial people hate me for saying that, but then if you can hit that spot, you've hit linear growth, or you've hit some kind of growth where you can throw money at the problem. And that's kind of what we hit at that point. Then we had the next scalability challenge, which was not technology, it was people. So now you've got more engineers. So they're not all doing everything all the time. Suddenly, maybe you want to have one ops guy, and maybe you want to have 2 guys building mobile devices, and one data infrastructure guy, or something like that. So we started to differentiate, and this is the beginning of a new era for our company, and it only gets more exciting, hair-raising. So it got bigger. Now we have to use the fisheye lens. So we knocked down the middle wall and expanded that way, and now the space was huge. We never, damn, huge. So we kept growing into 2013, kind of linear growth, and we sort of did hit our scalability, the golden thing you want out of scalability, which is just push numbers at it. At some point, SSDs came out, and we just kept pushing the number of MySQL boxes up, number of Memcache boxes up, number of Redis boxes up. And it's not quite that simple. You start to hit new issues. Number of connections becomes a hassle, network, all these other things. But in general, we were kind of past the database mega pain point and onto the next mega pain points. And we started to grow the company in terms of people pretty fast. Suddenly, to round off all the corners, you need product people, you need people to support them, you need lawyers and finance and HR and all these things, and suddenly your company balloons. And the challenge now that we start to get is that when you hit this 100 to 120, 130 range, people will actually come up to you who have been through this before, and they'll say, I'm sorry, because you're going through kind of a rough time. What you're doing is you're now having to make structure in your company if you didn't already have it. Some companies start with it, some companies don't. We sort of didn't. So now we have to have improving communication, feedback, manager structures, things like this. And that always comes with some hassle because this person wants to be manager, this person is a good manager but doesn't want to be a manager, all these things. And so any structure you come out with will have its own hassle. And you're also going through a cultural funnel. Because you're bringing a bunch of engineers, you worry, is the culture going in the right direction? We could lose the culture now, many companies have. What if we bring in 20 Google engineers all at once and they change it into Google? Is that okay? These kinds of questions are bubbling around in our heads. So we started to split it all up, and now we actually started to have individual teams. And this came with a lot of struggle, but when it came out in the end, it felt really good. It started to move fast. So you got data infrastructure, because now we have a full data pipeline. This thing needs to never go down, because the moment the data pipeline goes down, you lose your business sense of the whole thing. It's like a captain who can't see outside the boat. We have a search team. That was exciting. For a long time, it was a quarter of me. business and platform to actually support the business unit that was starting to grow. Spam team, because spam became a problem. And web, mobile, growth. We started having a growth team so that somebody is always looking at the problem of growth, our number one initiative. And then an infrastructure and an operations team. And then 65 non-engineers, meaning, I hate that term, but I can't come up with a better term. Product managers, lawyers, all the various other components that are absolutely necessary to get this thing rolling. And then we moved to San Francisco. We ran out of space in Palo Alto, thanks to Palantir. Anyway, but got big. This space would support us for the rest of time, but not quite. So we needed a bigger space, and now this is an old picture, and it's getting bigger. So now I think one of the biggest challenges we have at this point is we've always been in the same building, and so the context switch time or the cache load time of talking to the operations person for me used to be this. That's half a second. Now I've got to go down to the other side, and I know it sounds like a first world problem, but it impedes communication by a significant amount when you're not used to it. And now we've got another building. And how about when we have a building in New York? And these are the kinds of processes we need to build in, building culture around a virtual environment and managing that virtual environment. All these things have to be done very, very well, and we're beginning that process now. So technologies. This is a rough layout of our stack at the very, very high level. I wanted to keep it extremely high level, but it does give a good sense for how we think of things. We try to keep it dirt simple, and we also try to keep things a little abstracted. So someone calling Pinterest.com goes into ELB. We're hosted all on Amazon. So we use a couple of their Magic Black Box tools, and ELB is their load balancer tool. And one of the reasons we use it is it's actually got Magic hardware underneath, and if we need to deflect a DDoS attack, they can do that. But then we go into a software hour managed load balancer, and the reason we do that is that gives us a little more control. ELB is 2 black box. But at this layer, we can do things like shut off a university where a PhD student is going a little crazy, which happened a couple weeks ago. Then we have our Python layer, this purpley layer here. It's the business layer. It's currently Python, but it's shifting. It's if you come in from the web, we'll direct you to a web app where we'll talk HTML back to you. If you come in from the iPhone or Android or something like that, we'll go straight to the API. The web layer actually talks to the API layer now exclusively. That arrow now needs to go a little left. And that's nice. That gives a nice abstraction. Structures the whole tier. Task processing is done by a system called Pinlater, which is simply a MySQL box where you put in tasks, a name of a task to run, and some strings, and then a whole sea of Python processes will pull them out with priority. The reason why we moved it to Pinlater, if you are in the same situation, you can use something called PyRes. It uses Redis and it's a similar operation. It works very, very well. We eventually decided we needed a little bit more ACID-style compliance. And then every image on Pinterest lives in S3, every user-generated pin. And we get your initial image, and then we make a whole bunch of different versions, the small, the medium, the square, all that stuff. And then we front it with a CDN like Akamai. And then this is the part that's getting really interesting as we grow. We have this intermediate service layer, the yellowy boxes. And they're connected to the business tier with a connection management system built around Zookeeper. We don't have any load balancing between. We used to. That was a hassle. I would not recommend it. Essentially what happens is when a web app wakes up, it says, hey, I need a search service. And this thing will have a list of them, say, here, connect, and they direct connect. If one of these dies on either end, there'll be a little scramble, and we'll make new connections. If a new one comes up, we'll rebalance there too. It takes away a middle tier of hassle. Having an intermediate load balancer is its own little nightmare because you've got to say, well, do I need 10 of those? And you have to do shuffling, and then sometimes they just don't work. Mess. Got rid of it and happy ever since. And then the service tier is sort of where we're growing. There's a whole sea of different ways people do this. Facebook is a classic example. I don't know exactly what it looks like today, right now, but as of a couple of years ago, they were one giant code base with a few services. So they'd have big deploys, it would be a big thing, and they had a culture around that it worked. It worked well for them. Amazon's the opposite, I think. One request to Amazon's about 300 service calls. I think we're kind of going somewhere in the middle. I like to put it at kind of a boundary of a team. That's one way to look at it, or roughly a product. So like the search service is this one nice property you get out of this structure is the search service is this massive engine behind it. You do a whole bunch of nightly gathering of data. You have all these smart systems. I don't care as long as I can search for Star Wars and crochet and get little knit Yodas. That's all I want to see. So search service provides us that. The feed service is a service where you put pins in and it goes out to everybody it should. It handles it. It abstracts it away from me. One of the great examples of safety is the MySQL service. This is one of the first ones we did, and I kind of think of it like the code on the Apollo 13 or like on satellites, where it's really dangerous code to touch. One team will lock it down, write all the things around it, because what will happen if you mess that up, and this did happen, is someone will make a mistake, and it'll be innocuous at first, and then eventually something bad will happen, and your core data, which for us lives in MySQL, will start to get corrupted. So we had a situation, and I'll show you in a minute, all of our things are sharded, and what was happening was somebody would pull data out of one shard, edit it, and put it back to the wrong shard. So now just data started going all bad. So what you want to do is that one's a good one to have as a service, because you can lock it down. Only these people can touch it. They're super careful. If you want to make any changes, you've got to go through NASA and everybody else. And then we have things like the spam servers. My team is now working on that, and one of the nice properties of that is I get really fast speeds of deploy. We used to be part of the massive, kitchen sink code base, which is to me everything we haven't pulled out as a service. And when we pulled out, our deploy times went from twice a day, maybe not, to once every 30 seconds with tests and everything. So it speeds us up too. All of our data is in these four systems. HBase is a relative newcomer. We've been using it for about 1.5 years now, I think. But we're largely in MySQL sharded, which I can go to more if you guys are interested afterward, and Memcache and Redis. And then HBase is something we're using for new systems, and I'll explain why. And then also a first-class citizen, although I threw it on the side, is our data pipeline. This is one of the scariest things we build. It's one of the most important. Essentially, this is how we can see outside the windows, how we fly. So everything that happens on the site gets funneled into Kafka, which is it's like a giant fire hose. Everything goes in, and you can drink from the fire hose. It's from LinkedIn, really good. It's in the same vein as Flume and Scribe, but this one scaled very well for us. And then you drink from it. We have a system called Secor, which watches the logs, chops them, and then puts them in S3, where now you've got your magic 11 nines of magic durability. This system's a bit scary, because if it goes down anywhere along there, that data just evaporates and it's very hard to get back. So you have to have a really good, strong team around that system. One else nice thing about Kafka is you can watch everything that happens on the site, so we send it down for spam processing or any kind of stream processing, so that if a whole big attack happens, we can react to it within milliseconds. Once it's in S3, you can do anything you want with it, because everybody talks to S3 these days. Send it over to EMR, that's Amazon's MapReduce, or send it over to Qball, that's someone else's MapReduce. Amazon also has Redshift, which is a flavor of MapReduce that's a little more structured. You can't do as much, but it's much, much faster. So once you're in S3, you're home free. So if you're interested in the sharding, I do have a talk on what we did for our sharding. You can go check it out. If you want to, we could talk about it afterward. I go into how we landed on the sharding we did, how everybody else does their different flavors, and why we chose this one. We learned from many mistakes and then made the next step. Around September 2011 or so, when everything was on fire and we wanted to re-architect, we kind of had this problem of how do we choose what to choose, and this is how we sort of drove the technology we'd use, and then finally how we drove the sharding technique we decided on. We kind of had this gut that anything complex was evil, so we didn't want to do that. And everybody, I've run into this problem all the time today, is I wonder, why are you using these NoSQL technologies? Why are you using all these different really amazing new technologies? And this one person summed it up nicely for me, and then I had to beat him up afterward. He said, well, I'm building the latest and greatest. I need to use the latest and greatest. And yeah, no. If you need a flux capacitor to make your time machine go, and that's brand new hot shit, use that, fine. But if you're building yet another really cool social network or some other flavor of that, you need a database. Well, they've existed for how long? I don't know, 60 years. And MySQL has been around for a long time, so use that. It will do what you need mostly. We made a list of questions to ask ourselves. So first, does it meet your needs? Well, if it doesn't go back in time and you need a time machine, it's going to be a problem. But most of the time, you need to at least make sure that basic thing will hit. So one example is MySQL can do a lot of things, but one thing it doesn't do well is, say, like if you want to look up by geography. Not good for that, so you may need a different solution. How mature is the product? This is the biggest question I think that most people get wrong, especially when they're building their little tiny startup. So I had to define it. What is maturity? Well, to me, maturity is the blood and sweat that's gone into something divided by the complexity. So blood and sweat's like, again, MySQL is a good example. Facebook has poured in a lot of resources into it. They've beaten that thing down. They've seen every kind of problem that can happen. And an example of why MySQL, an example of the maturity is you can go and find any answer to it. There's a bunch of things that fall out of this. If you have a problem with MySQL, the answer's out there. And the complexity is the other side of it. So Memcache, an example, is a hash table with a socket. You can't get any simpler than that. And that sucker was mature roughly on the week it was released. And it's been beaten down for several more years. I think it's about 10 years old now. So that thing just works. Kind of on the flip side, if you take a technology like Mongo, it's really growing fast. They've got a lot of blood and sweat going into it, but it's a bit more complex. And the blood and sweat compared to something like MySQL, much, much smaller. So you've inverted this, and now you're saying, let's go to market. And that's a problem I think we run into a lot. So out of maturity comes many properties, and these are the next couple bullets. For one, is it commonly used? Typically when something's mature, people have used it, there's people out there. So for example, HBase, which we now use, we couldn't hire for. There's nobody out there. And if there are people out there, like we now have 2 homegrown HBase experts, we manacle them to their desk and don't let them go. Versus MySQL, if you're in downtown San Francisco and you faint and someone says, hey, we need a MySQL expert, there's one out there, guaranteed. So that's a really big concern. Can you hire for it? Is the community active? And I'll tell you the example that I remember with this was it was 2 a.m. and I had a MySQL problem. I went on to Google and I said, replication key failure. Oh, and there was a million articles and you go onto Stack Exchange and it says, here's how you solve it, and then they call you a noob. So I'm like, oh, wow, okay, mature. Versus something like Membase, there are 0 answers out there. I finally found some little chat room somewhere and the guy was asleep. He was logged in, but he was asleep, so that was great. How robust is it to failure? Well, MySQL, I'm going to keep saying MySQL. This sucker, I've never lost any data on it, and in the grimmest days, I remember the hard drive had crashed and there was some other problem with the machine. I could barely log in, but I got in, and I found some random tools some guy had written because he had this problem, and I slowly sucked out the memory and got it onto another box, and I lived another day. Unlike some of the other technologies, as they grow, I don't want to pick on too many of them, but you run into a problem. Hard drives have a little problem, there's a little bit of corruption, and we had the CTO come to us for their particular technology and say, sorry, data gone. Fortunately, we never trusted anything besides MySQL for our golden copy of our data, so in all the events when we had catastrophic data loss on these other technologies, we were able to rederive it. Next one is how robust, does it have good debugging tools? And this always comes with maturity because someone trips across the thing, they want to profile it, they want to make it better. So you get things like online backups, profiling, all those things. And Membase, as an example, I couldn't find any of that stuff. And MySQL's loaded anything you want, it's there. Then you have to get into questions about how well does it scale. Well, MySQL doesn't scale past a box. So that's the promise that NoSQL gives you, is you just add a box. That's awesome. I wish it would work. And it does work. It's getting better, but it's got its own set of issues. So MySQL, we had to layer on some scalability to get it to go more than one box. And then finally, it's a cost justified. We didn't really play this game, but many people have this question about, do I go and buy the big IBM DB2s or the Oracles of the world? In our case, we didn't really have an option. We were a small startup with no funding, so MySQL it was. And I think even if I had the money, I think I'd still consider MySQL. But that is a question you have to consider with anything you build. So why Amazon? I've been asked this so many times, I thought I'd just do a slide on it. And actually, this goes back a little bit to the days when everybody was wondering if we should do data centers. So it's getting a little dated, but I think it's still relevant. If you haven't used it, it's a variety of different servers, and you can run Linux or Windows. You have the option of managing it yourself, but they also have a lot of little tools. So if you want to not deal with your database, you can use RDS or Dynamo, and RDS is like a Oracle or MySQL clone, and Dynamo is like a big table kind of clone or a Cassandra-ish thing. You can use their load balancing, which we use, their DNS, we also use that. They have MapReduce if you want it on day one. We used it for a long time, but it had scalability issues we had to get around. They have basic security firewalls and everything built around it. I'd say the reliability is good. I've been in data centers, I've been in AWS, and everybody likes to rag on AWS, but to me it's been very, very good. We've had our big problems, but we've recovered from them. The community is good, and they're not cheap, but the promise of a new box in seconds changes your whole world, especially from the old days when people would ask about data center. Now, if I need a Memcache box, I can get it now. I can get it at 2 a.m., no question. In the old world, I'd have to plan several months ahead and hope I get it right. We use Route 53 for DNS, if anybody's curious. ELB for that first top-level load balancing works very, very well. Managed EC2 we use for most everything else, and then we use S3 for our images and our logs. Python. We're primarily a Python house, but we're shifting slowly. I love Python. I'd do it again if I had to. It's extremely mature. I don't know of any bugs we ran across. The community was really, really good. It seemed like our dev was a lot faster. I come from the PHP world, and I felt like it was a little bit more structured. And not too structured to the point where I have to make a factory just to get an object out. It seems like I can move fast. The libraries are very, very good. I think one of the most effective rapid prototyping tools we can build that's available. The only problem with Python is that it's an interpreted language. And the garbage collector, I couldn't find any info on Google about. So I'm like, is it generational? What is it? So I went and finally read the source code, and the source code for the garbage collector is this long. And if anybody's written a garbage collector, you know that's too short. So it was too short. And so to me, that meant it was probably stop the world terribly, and it was. So that's a problem with Python, so you eventually have to deal with that issue. But we're just now dealing with it at the scale we're at, so I'd say if you're building something new, go with what works and what's fast, especially for your developers. So if they're Ruby people, do Ruby, whatever works. We're now moving to Java and Go for a couple of core services and maybe for bigger systems, and that's primarily for the speed reasons. We use Python for everything, most of our services, and now Java and Go, we're starting to use anywhere where that we really need to be fast and the variance needs to be low. So we're really tightening up our SLA. So that's like at our varnish layer for load balancing. Our search indexers are all written in that. They've got a lot of work to do, and a lot of CPU computation. Many of our systems, by the way, just kind of turn around and do a lot of routing. So CPU computation doesn't play in, so you can get away with Python just fine. And then our high-frequency systems like the MySQL services and our Memcache routers and all of that stuff is now moving to Java. And if you haven't used Go, it's kind of cool. I kind of like it. It's got kind of the nice mix of Python and Ruby, but it's compiled, and it's got a growing garbage collector, and the community is growing very, very fast. Okay, so MySQL and Memcache, this is kind of the punchline of the thing. These suckers just worked for us. They survived everything we put against it. Every other system in our stack has died in a catastrophic way, and I can go into that if you like a little bit after. It's extremely mature. Both of them are. They're well-known and well-liked. Everybody loves them. Everybody uses them. If you haven't used it, if you're not just a user of it, you may have developed it. You know, these kinds of stories. The response time to request rate decreased or increased linearly for us, meaning that it wasn't just one day where the thing got super slow as we grew. It sort of went down to where it was intolerable. So that was really nice property. Certain other technologies we found between 6 p.m. and 10 p.m. we grew up a little bit, and we went past some magic cliff, and that was it. And we went from 10 milliseconds to 4 seconds and had to get more RAM, essentially. That's very hard to plan around and makes me sweat. So I love this property. Very good support, so there's extra backup for online backups. Works very well. In OTOP, you can tell what's going on inside MySQL. MatKit will tell you about MySQL and Memcache, and the community is very active. Facebook uses MySQL and puts back to it at a very rapid clip. We use it for our primary storage of our main core data, all our users, boards, pins, comments, domains, things like that, and now monetization and other major data. We separate our things into mappings and core objects, and I'll explain more about that. I explain more about that in the sharding talk. There's a lot of advantages behind splitting those two out. And then we use it for things like legal compliance data where we need ACID compliance because otherwise the lawyers yell at me and then I get scared. Redis. This is the one that kind of surprised us a little bit. This is new. Not as nearly as much blood and sweat, but the complexity is pretty small. If you ever look at the source code, it's kind of weird. It's kind of cool, but it works. It's very simple and works very, very well. The community is very good. People are loving it. People are putting a lot back into it. A lot of people are adopting it. Twitter has it. We have it. I think Facebook was messing around with it a little bit. So big people are using it right now and hurting it in new ways. The cool part about it is, if you haven't used it, it's a key value storage, stores down to the hard drive, and it comes with a bunch of different little technologies, data structures. So if you need a set, if you need a list, if you need a sorted set or a hash table or any of that kind of stuff, they support it. And even cooler on the cloud is the different kinds of persistent modes they have, your durability modes. So you can have store it down to the hard drive now, like MySQL does. You can never store it down, kind of like Memcache. So if the box goes down, it evaporates like a classic cache. Or you can have snapshot, and this means store your brains down every 2 or 3 hours or whatever you set. And that's kind of cool, especially on the cloud, if your neighbor starts partying at 3 a.m. And your latency of your hard drive starts to go up, if you can do snapshot mode, there's a pretty good chance you won't store down on that time frame versus MySQL will grind to a halt. So we did that for our main feeds. We have a push model. So every time, if I follow all of you and anybody puts up a new pin, it will come into my stack. So snapshotting was a perfect model for that because if we have 100 of these boxes and mine dies, I may go back for a couple of hours and back in time, but then it will replenish and it really simplifies the whole model and it's a trade-off of that weird behavior for much better uptime. And it's also open source, so it means you can fix things. I've fixed many things in Redis over the years, just as we hit the new problems. We use it for our whole follower graph is stored in Redis, and this is our golden copy of our follower data. So we put a lot of trust in this, and we've been doing it for about 3 years now. So that means all of the little relationships, and Pinterest follower model is kind of complex. It's you can follow boards or users, then you can follow users, but not that board. These kinds of complexities. We store it all in Redis. We store our public feeds in there, and the reason we store our public feeds in there is, and not something like MySQL is still living in the 90s. It's one of its weaknesses. It's living with the Macarena and everything else. It's a tree structure, so that means every time you want to insert something, you put something on the top, you have to walk a tree. Well, everything we build these days seems to be some flavor of social network, which is a FIFO queue. So put on the top, read the top 20. That's what Twitter is. It's so simple. But MySQL is this tree structure, and so it is slow. And I've talked to them about it, but it turns out Oracle, MySQL is built around this tree structure from the core up, so it's a little hard to change. But if they can get that fixed, I think that could be a great solution. Otherwise, what happens every time you insert, it's slow. It doesn't work very well for mass inserts. But Redis did. Redis actually has a true notion of an ordered list with an O of 1 insert, and it all sits in RAM, so it's blazing fast. And we use it for various caching mechanisms too. It's very nice for caching. Like if you want to store someone's board to the list of their pins, you can make it a list of pin IDs, and you can say, give me the second set of 50 or something. So why HBase? Why, after I ragged on this kind of technology, did we bring it in? It's got a growing population of core dedicated users, and it worked fairly well. And it's got some nice properties that we couldn't replicate with MySQL or Redis. One big problem with Redis is that it all has to fit in RAM. So if we have a really good active rate, say like it's 50%, 60% better or whatever, that's still a large chunk that are not using the site and we're wasting RAM for. Or if we show people 500 of their feed and we want to let it go to 10,000, can't do it because it only sits in RAM and it costs us a bundle. So HBase has that nice notion of an actual fast insert. It's an O of 1, a pin to the end, massive fast writing system. So it now supports our home feeds. It's really fast. It's difficult to hire for. We had to grow our own HBase experts. It does have nice, strong Hadoop integration. So if you want to do MapReduce, you can link in immediately. And the performance has been really good. Big people use it like Facebook, so they've tripped over many of the problems we've had. I'm starting to wonder if everybody's continuing to use it. I've started to hear stories that maybe they're going away from it. There's questions about its scalability. The promise is that it has massive magic scalability and it's efficient. But I'm starting to wonder if that is actually happening. And I'm wondering, I want to look at it over the next 2 years and see if that promise plays out. The core idea is with MySQL, if we want to have a sharded MySQL, we have, say, in number of boxes times 2 or maybe times 3 because we want backups. That's in times 3, that's pretty expensive. But for this one, if you have a cyclical ring and you do all this magic sharing, you can actually get it down to, in theory, n plus 2 for backup or plus 3 for backup. That sounds really cool, especially as you get really big. But I'm wondering if the actual promise is playing out. So I'll let you know more as I find out. So we use it for user feeds, rich pin details, works really well. We put spam features in it. This thing is really operationally nice. You can just make a new table and it flows out everywhere, so that's kind of cool. So if the promise plays out of scalability, then this is a really great system to invest in. And then we also have a mapping of user relationships to pins. So what happened to some of these technologies? And mind you, this is now 3 years old. So many of these have matured way past. What I want to use is this is more of an illustration of what happens when you use a product that's not quite as mature as you like. And all these technologies failed on us massively in one way or another. And I know that many of them have gone way past their initial spot. So I'll kind of go through some of these and answer what happened with them, but I won't pick on any individual one. So did they meet your needs? For all of these, we needed either counters or search. So yeah. How mature is the product? Well, this was the problem. We didn't answer this question. All we had were these people coming to us saying, hey, use this technology. We'll scale to the moon for you. All your problems are solved. Sign up. Then is it commonly used? We didn't really answer that question. Many of them are not. Membase is a classic one that I think came from Zynga and I think is now being kind of dropped under the rug now. It's not commonly used, and it was very hard to find any answers. Certainly nobody who knew how to use it. So what I ended up with certain technologies was my cheat sheet of how to use it, and I eventually published them for other people. With Membase, my classic favorite one was it had an error message that said something like 07EFAB is opaque. I don't know what that means. So eventually we had a cheat sheet of that. Well, that means this, and so this is what you get out of it. Kind of dangerous at 3 a.m. Is the community active? On many of these, they were not. So there were 0 answers for any of these. On one of them, around 2 a.m., the thing just broke. And there's no way to fix it. I added in a new box, started the magic replication, starts going, and around 20%, it stopped. Okay, what do you nudge? There's nothing to nudge. Nobody's given you any extra tools to nudge. The thing has a bug. What do you do? So what I did is between 2 a.m. and 6 a.m., when the sun came up, I got it back onto MySQL Memcache, and then problem solved. How well does it scale? Well, that's the whole promise. These are really cool if they would work. Does it have good debugging tools? They didn't. Many of these did not, and there were major problems around that, so you couldn't even find out what was going wrong. So you've got a problem, you don't even know what the problem is, and you're trying to solve it. And they're all free, so there wasn't really a problem here. They all had many of these have different support contracts, and some of them are very strange. So that's another thing to look at. If you need support, some of these had such strange support contracts we couldn't even buy them. It was either too expensive or too mind-numbingly complex. So if I had a second chance to rebuild all of Pinterest, I love going through this every once in a while. The first thing I would have done is put logging on day one. We did it in terrible ways. We had a MySQL box where we logged. MySQL is a bad place to log. It's a tree. Who needs trees with logging? So what I would do is I put it into Kafka and make a little thing to put it into S3, problem solved. Then you get MapReduce on day one. Learn how to use MapReduce. There's SQL 101. It's easy. It just takes an hour. I'd also use StatsD. StatsD's been really good. We're running into a couple of scalability issues with it just now, but it's worked with us for the whole time. It's from Etsy. Essentially, you say, send a counter that way. It's a UDP packet, so you don't have to worry about that other system breaking. And you can send counters, bumps in counters, or you can decrement if you want. And you can send timers. So you can say, this process took this many milliseconds. That's really simple to set up and really nice to have. And then I'd also log everything. It will save you on some day where you screw up MySQL. If you're storing all your stuff on MySQL, you corrupt your data accidentally, go to your logs, the data's in there from yesterday. And you can recover it. You also get basic analytics about how your site's doing and recovering from data corruption. The other one I would bring up is Nagios or some kind of alerting on day one, Munin or, well, is it Munin? Monit or Nagios, one of these on day one, because even though it's designed to wake you up when there's a problem, it will get you sleep. In the early days, one of our founders would wake up every hour in the middle of the night, roll over, check Pinterest, good, it's up, go down, go back to sleep. So when I brought it up on the first day, he was like, Marty, I can sleep again. I started losing sleep now because it started waking me up. Other things I would have done, we started in September on that graph when everything was already hot. So when you decide to shift to this sharding approach, you've got the problem that you already have a site you have to maintain. You're trying to build this new thing, and you're trying to transfer data off. So you're trying to take a little extra load from that thing and put it over here. So that was a nightmare. I wish we had done it earlier. It's a little hard to know when, but my one little hint to you is typically what happens with any database, especially if you're using MySQL, is the first thing you do is say you have a pins and a follower table. You take the follower table, put it on that box. Oh, you have double capacity now. Great. Well, that's only going to last for so long, so the typical thing you do next is you start making read slaves, and you make more read slaves, and you make more read slaves. The moment you make your first read slave, that's the hint you should be looking at sharding right away. In fact, the time bomb has already started. The problem with read slaves, there's many of them. One of the biggest, most irritating things is that they make these weird subtle bugs. You put new thing in MySQL, you clear the cache, and somebody else reads before you actually replicate the data down to your read slaves. Problems, pain in the butt. The moment you start thinking you need to do that, that's when you should be looking at a sharding solution. Email me, we'll party. We also kind of fell into that NoSQL trap because of the problems we were in. Everything was on fire. I would watch that closely. I think you may want to consider many of the things I've been hearing from companies. It's actually the flip. You would think that NoSQL would be good in the early days because it solves your operational hassle for you. It turns out many companies, the time when you can actually support a NoSQL, they get kind of excited. Hey, we can have a few engineers who can actually support HBase, and we can use that technology for its good properties. In the early days when you have 2 and 3 engineers, I'd say stick with what's simple, stick with what will work, stick with what will be fixable at 3 a.m. when the thing's broken. We also used a lot of weird technologies for background task processing. There's RabbitMQ, classic clusterable technology where you put something on one end and it comes out the other. Way too complex, didn't scale with us. We eventually went to Pyrez, which is just a collection of boxes that feed from Redis, and we learned that Redis works very, very well. So Redis is a giant feed, put stuff on the top, you say, I want to run this task, see if Python processes, takes one, runs it. Couldn't be simpler. That simplified everything we had. The other thing I would recommend is, in the early days, we also just had one funnel of all tasks. That's dumb. You should split it out into the important tasks and the unimportant tasks, maybe even prioritize. So one example is, if we want to create a new pin, and we will have a couple tasks for making new images, we need to do that now. But if we need to send out tweets, that can wait. In fact, that could even wait an hour, if the other things are broken. You want to make sure the high things work now. I wish we had hired a technical operations person earlier. The moment that guy came in and started doing the chef and puppet steps where you puppetize everything so you can bring up a box by pushing a few buttons, that made everything a lot easier. We used to have these, what I called Apollo 13 checklists, because what could go wrong? And you'd go down the steps to bring up a MySQL box, and hopefully you got them all. But it would also take a while. So Puppet made it so that all of our boxes could come up pretty fast. If we needed to change one property across all of them, they would magically go across all of them. So it gave us scalability. I wish we had done it earlier. And unit testing might have been also a really good choice earlier, rather than just kind of hoping for the best. And finally, A/B testing is something I wish we had brought in earlier. It's very easy to add on what we now call a decider. You can build one in a day, a simple version. Basically, what it allows you to do is say, you have a whole list of different kinds of properties, experiments, or whatever you want, and you have a little little slider. So you could say, this brand new thing I'm bringing in, I want it to bring it up to 5%. Okay, it works, now 10%. Okay, it works, now 100%. Or if a non-critical system is broken, you have kill switches so you can turn it off instantly. So you can build this system, you can make a little simple wrap around it. I may even have it open source, I'm not sure. And then the idea is that it's in MySQL, it goes up to Memcache, and you say, should I show this or not? And it gives you a little routing inside your code. Really convenient. Last thing, looking forward, we're now growing to beyond 400 people. We're now hitting things like, how do we live virtually? How do we build out the next big thing? How do we get faster? Essentially, how do we build more Legos so that we can build product twice as fast and twice as good? That's kind of our current challenge. So that if we can get that funnel going really fast, if we can have 400 experiments going at once instead of, say, 100, that gives us a lot more opportunity to see the next 5%. And if we can keep layering on those 5%, we'll go to the moon. And then in continuing to improve our collaboration is very important, because as we get bigger, collaboration gets harder. And my final little thing to you is just have fun with this thing. Culture is a big issue in many companies. There's many that have failed due to toxic culture they built. And I found that in the beginning, if you make the culture fun, people like to come there. They like to spend their daylight hours with you, and they like to have fun building things with you. So if you're building a new startup, kind of focus on that if you can. Make sure that your people are having fun, because this damn thing's struggling hard enough. So no, seriously, have fun. Take that to heart. Are there any questions? Zookeeper. Yeah. Yes. Oh, thank you. So the question is, there's a different technologies. MySQL is simpler in complexity, and there's Cassandra is much more complex. What about something like Zookeeper? So Zookeeper is built on a Paxos-ish thing. I don't think it's actually true Paxos for getting to consensus. I wonder if it was the right choice. It seems to be working well, but it's gone through a lot of hassle. We use it primarily for configuration management. So which boxes live where and pub sub and this kind of thing. I wonder if Redis might have been a better choice. Close enough, eventual consistency. This thing will tell you the moment everything is the same, but you get split brain problems, you get all these other problems. So if you're going through the exact same thing for configuration management, I think that'd be a very good question to ask. I know we've had our hassles with Zookeeper, but at the moment it seems to be working. I wonder if something like Redis or just storing it in S3 might be fine. You can do some kind of a pub sub-y kind of thing there or some kind of simple polling. More questions? Cool. So if anybody's interested, I can go out here and talk about sharding if you want to get more into the nitty-gritty or any other questions you have. Thank you.